Hi, good afternoon all, and welcome to this keynote. A bit of an unusual keynote event online, but hopefully we can get that through. I'll introduce myself. My name's Paul Needham. I'm head of engineering at BAE Systems for Air and Space Products. I've been with the company for over 30 years now in design and manufacture, predominantly of airframe. I've extensively done work in the US on the F-35 program as head of engineering for there. And my title though is professor. I'll explain that. I'm a visiting professor of Huddersfield University in the School of Computer Engineering. So I do a little bit of academic work with them to do that. Okay, so I'm going to take you through some of our products and the challenges and the future, what the future holds for engineering at BAE Systems. So got some good facts and figures. I like facts and figures around BAE Systems. So BAE Systems is one of the world leading global defence companies and innovators across the globe. We have established positions in air, maritime and land. I know we're predominantly known for air, but we have products, complex products in both maritime and land position, with a growing cyber security network. Principal markets are around the US, the UK, Saudi and Australia. And we have 90,000 employees, over 40 countries. And our customer base is around 80 countries worldwide. Sales for 2021 was 21 million. And, you know, important, growing our engineering capability. Last year in 2021, we spent £72 million on apprenticeships and early careers. We almost spent £100 million on skills and training to develop our engineers for the future and what the future demands are that are coming through. So a bit of an overview of where we are globally. We're probably recognised in the UK and that's where we're positioned, but we probably have nearly as many engineers in the US working for BAE Systems Inc. as we do across the UK, with Australia and Saudi Arabia. So we're a global organisation across the globe. Our main markets. The US does represent the single largest defence market in the world, and we, as you can see, we're a significant part of that, and we're in the top 10 of defence suppliers in the US. And BAE Systems is the largest defence company in the UK today. Our markets, including Saudi Arabia, is one of the largest defence markets globally, and in Australia, we are the largest defence organisation in the Australia market at the moment, and also other international markets with BAE Systems create strong relationships across the globe. So I'm going to go and do most of this slide is around about the air products and what we do in air. So I'm going to talk about the air business, which is a large part of BAE Systems. So air product is the sovereign provider of the combat capability across the UK. We have international markets and customers right across the globe. And we have a track record of collaboration with our customers. It's becoming even more important these days to integrate complex products, complex designs with our products. And that's what we are benchmarked with for multiple suppliers and multi-collaboration organisations. We have a strong technology pedigree, and I'm going to talk a little bit more about our technology in the coming talk that comes through, and skilled and experienced workforce, as you would well imagine. We continue to contribute to both national and regional economies around the UK, and that's a really important factor for BAE Systems as we're coming through. Okay, I'm just going to go at a glance around about what we have here in terms of within the air program. So Typhoon is a big part of our organisation, both production and support, and availability support contracts that comes through. Hawk product is a large product, and a bit more detail in the coming slides around about that. But Hawk is a trainer and to training support. F-35 program, we have around about 10-12% on the F-35 program that we are involved in, and I would suggest some of the most complex technology and manufacturing has been developed on F-35 up in the northwest, where we produce some of the complex products that we do. And looking forward to the future is what's going to replace our combat systems is going to be the future global air system. So it's our vision to get this collaboration up by 2035, and it creates another leap and demand for technology, engineering for future products as we go through. Again, training is a big part of what we do, and I'll mention that a little bit later about how we train pilots is really important, because it creates that sustainability and reduces global footprint, and the amount of synthetic and training requirements is really on our agenda. That comes through. Typhoon capabilities. The Typhoon jet is always getting upgrades, with upgrades capabilities and the development through Typhoon capabilities forever going. New cockpit, new systems, new radars to keep up to date with it. Information advantage is another part of the air system. You know, information is really important, and the power to translate that information for our customers is really important. Research and development, again, big part of what we do. It makes a difference to our customers, and the picture you can see there is Phaser 35 as just an example of some of the technology we do. This is a solar electric unmanned air vehicle, and this is potential to transform the air and space market, and it utilises world leading technologies, including advanced composite systems and the ability to manage energy. So they'll collect energy during the day, store it, so it can fly. I mean, this can fly up to a year in the stratosphere, and the rechargeable cells are maintained, so we can kind of keep that. Probably replace satellites in that stratosphere zone. That comes through. And I suppose another important part of our sector is we do a significant contribution to the design and manufacture of missiles with MBDA, and that's 37% of MBDA is owned by BAE Systems Air. So major programs coming through and going a bit more detail into some of our major programs and the significant contribution that we've come across the UK over the last 60 years across Europe, with some of our major contributions going through there. So Typhoon is really the backbone of the combat air defence system in the UK, and we have a number of European international allies that develop that system that are coming through. We continue to invest in Typhoon and maintain its cutting edge military capability, and we're developing technologies so it's to the centre of the next generation of our combat system, and then that technologies will leap onto Tempest and future programmes as we go forward. So we've got over 600 multi-role combat aircraft on order, and 9 nations across the world use this platform going through there. So, you know, Typhoon, the first tranches of Typhoon will probably now be coming out of service in 2025, but certainly Typhoon will be around for the next 2, maybe even 3 decades as we move forward. Hawk, as I mentioned before, Hawk is the world's most successful proven military aircraft trainer we have today on the globe. Over 1,000 aircraft have been ordered across 19 nationals, and it's a training platform for the fast jet support that we do. So we've achieved over 3.5 million flying hours, and also trained around about 25,000 pilots for them to go on platforms like F-35 and Typhoon as we go forward. Lightning II, we have a big contribution to Lightning II, F-35 Lightning II, and we were involved as a partnership with Lockheed Martin, and predominantly we designed and built the back end of the orange parts there of the aft fuselage, the horizontal and vertical tails, and on the carrier variant, as you can see, those folding wingtips that fold up and down to allow them to get access onto the aircraft carrier platform. We were also involved in the crew escape and the life support. We designed and engineered that for the program, and also the fuel systems on the aircraft. So we're involved in a lot of the systems that come in there, not just the airframe side that comes in, and also the BAE Inc. side was involved in the electronic warfare system and radar system that comes on. So F-35 is the largest military aircraft in the platform in the globe today, and we contribute massively towards that. We've had over 700 aircraft delivered so far, and is now operated in service that comes through. So that the parts are manufactured in the Northwest and then sent out to Texas, where it's assembled and flight tested to the relevant customers. So here's to the future is Tempest. So Tempest is going to be the vision of our global competition. Tempest plan will be to have initial operating capability in 2035, moving forward there into full operating capability by 2040. It's going to be an international collaboration future combat system, and it's going to have probably a number of partners across the globe that are going to help and devolve this into the next generation fighter. And we want this to remain the choice of how the UK evolves the capability in multi-domain system of systems. What you see there is not just an airframe, it's the systems that talk and communicate right across, and our engineers involved are right across the platform as it comes through. And the systems must be flexible, upgradable, cutting edge, and affordable and exportable. I want to pick up on that affordability side. As engineers now, we need to think how we design complex parts, but how we drive them and make them more affordable as we go through. So to do this, we're developing game-changing technology. We're attracting the next generation of engineers to help on this and transforming how we work at a higher and more efficient pace than we've ever done before on any other platform. Partnering and collaboration is really important. I think I mentioned that before a little bit about the integration and the integration of engineering across the platform. Keeping on Tempest, you know, our national endeavour, Tempest programme already employs around about 2,000 engineers across the team at the moment. More than 1,000 apprentices and graduates have been recruited across our partners. 28% of BAE Systems workforce are under the age of 35 on this programme. So engineers today, this will be the future for them. I was lucky to be on the F-35 programme, and this is where the future engineers are going to build the knowledge and pass the knowledge on for the future. You know, to contribute, this can contribute 20 billion plus to the UK economy between 2020 and 2025, and on average will bring 21,000 jobs over the year. And the average worker is estimated to be, you know, substantially more productive than ever before, both in engineering and UK as well. 70% of the programme value will be generated in the northwest, southwest and east of England. So this is a really exciting future and a programme that we're excited to be part of as we move forward in this. So I'm going to talk now a little bit more about the future and where that goes, and transforming the future, and what engineering looks like in the future. And again, feel free to ask questions. I've got a few questions coming through about technology. We can have a discussion towards the end about any questions on where we think we're coming through. So please throw your questions in. So technology programs, as we move through, is as you would imagine on BAE Systems, we have a super wide array of technology programs. So this technology is going to make a step change on programs like FCAS and Tempest moving forward. So technology insertion, that we come there. We've got smarter factories and support systems of the future. And the art of this is bringing technologies to help with our existing process to do things faster and smarter than we've ever done before. You know, integrating intelligent workstations is an example of that, and core robots. Airframe technology, so we're transforming technology, transforming our manufacturing capabilities, and these are going to be driven by how we design and engineer things. So we as engineers can help manufacturing deploy additive layer manufacture, advanced materials, and you can see the robotic and core robots. So aircraft will be built by robots, and the core robots is human and robot interface working together. But what we need to think about as engineers is how do we design the product from the early stages to enable manufacturing to exploit that and exploit the savings that we got. That's the real challenge moving forward. Future technologies, again, it's not just about the airframe, it's about, you know, the data and the data that transfers round to different platforms that come through. So data and controlling data is going to be a big piece of what we do in the future. Embracing and exploiting digital technologies right through across the life cycle is really important, from design, manufacture, in service and supportability. That digital thread is something that we've got all the way through there. So if you look at on the slide, the cockpit and human factors research is, you know, we have human factors team, which is engineers and psychologists working together to create the best environment, the most efficient and safe environment for the pilot to operate in. The human factors and psychologists engineers work very, very closely with engineers to create the right environment for the platform and the customer to do. And it's a really piece of interesting field of work that we do. And it's a really good example how different capabilities, different knowledges work together with engineering to help create a platform that's fit for the future and what our customers want. Okay, moving forward is again is something that we're very proud of at BAE Systems, is our airworks and our factory of the future. This is the first of its kind factory of the future. It really is like walking into Starship Enterprise, as you can see when you walk into Factory of the Future, and it embraces aerospace industry 4.x and engineering 4.x. Now you might see on my slides there at the bottom right hand corner is engineering 4.x, and that is BAE Systems opportunity and strategy to transform engineering for the future. There's industry 4.x, but we're taking that a little step further and saying, what do engineering need to do differently to create these new products, to create these new environments that comes in. And this environment, this airworks environment we've got, is a multi-million pound investment, and a collaboration again of some of the top 40 blue chip companies and SMEs across the UK. And it's enhancing the best of the UK innovation and allows us to get that digital connectivity and intelligence through into the factory of the future. But it's really super important that us as engineers ensure that we have engineers and platforms to enable people to exploit this technology in areas such as airworks and air labs. A lot of that will be moving from, if you want, conventional, you know, back in time you'd have drawing boards and that type of thing. We're now moving into a model-based systems engineering environment, and that environment will allow us to do things quicker, smarter, and more importantly, deal with the complexity. So our products are going to get far more complex than we've ever done before. And how do we do that and do that quicker? It's we change the way we do in terms of engineering, and that model-based engineering approach and systems engineering is centric to our strategy moving forward. I mentioned transforming engineering to meet the future need with engineering 4.x. So examples of that is we're trying to get engineers more broad knowledge. So absolutely we have our SMEs in there, but to get a broad knowledge of engineering to move things at pace, and we're upskilling our engineers to be multifaceted in various domains and disciplines, more at a capability level than a discipline level. And that drive is to help us to become more agile. How do we benefit from this? You know, our designs are right, our engineering's right, we get this robot assisted assembly, you know, autonomous mobile robots, digital connectivity across the supply chains, which again is super important because most of what goes on our products is made in the supply chain, and the supply chain needs to be ready and agile to deal with this new way of working, this new digital connectivity. And we work with our supply chain organizations to get that right. So there's no 2D drawings, you know, everything is done digitally. And we need to work with our supply chain that they get ready to do that. Data-driven processes, advanced manufacturing technologies, and intelligent manufacturing systems. All these really good technologies live and breathe in this airworks and factory of the future based up in the Northwest. And another part of what we do is looking at air labs, as well as the physical side of it. It is as important to look at the digital side and how engineering transformed digitally. So the Air Labs is leading the way in digital transformation across the air sector by high performance teams working in this environment, connecting test and evaluation. So we need to start to get digital test and evaluation to make it quicker. Wind tunnel testing, material testing in the future will hopefully be digitally driven, so we can get decisions quicker, more agile and flexible to the engineers on the ground there. Lots of digital stuff there, technology demonstrators and mission systems, battle space, all within that digital is being developed in that arena. I don't know whether you can hear me, but it seems my screen's frozen here. Oh, good. I think we're back online then. Sorry about that. And again, what is super important and another challenge that engineers have to have is sustainability. How do we build sustainability into our roles? It's crucial that we design and engineer products that are more sustainable moving forward. How we do this and what we're doing in terms of, you know, our customers want to know what we're doing in terms of our environment and what we're doing. And I mentioned the trainer and the digital trainer that's coming through at the moment, and these create some really quite astounding improvements in what we do. So pioneering new technologies in low carbon footprint. As the RAF reach forward, they want 80% of the pilot training to be done virtually by 2040. And in 2020, we completed around 9,000 virtual training events, 13,000 hours of flying, which saved 180,000 tonnes of CO2. 9.6 tonnes of carbon is saved with every synthetic flight that we do and train the pilots. And the mission for both us and the Air Force is to allow pilots to train in this environment to save on the carbon footprint. And engineers are right behind this, working the technology, working the digital technology as we go through. And it's super important. And again, some of the products that we are developing moving forward in the environment is, I mentioned Phaser 35, which is our unmanned solely battery powered aircraft. We're also looking and developing electrical lift aircraft for the customers, and our vertical takeoff and landing. All this technology is being developed to allow us to get into this environmental space, to allow customers in the environment. And this creates a huge challenge for engineering. You know, it creates thinking a bit more out of the box about, we've got to be more affordable, we've got to be cheaper, we've got to be more sustainable in what we do. And that's why Engineering 4.X has come and started to develop that. So the contribution to the UK economy is really super important, and it's really important that us at BAE Systems help and grow the UK national. And you look at some of these data that we have, for every 100 jobs that we have over 400 jobs that support what we do across the UK economy. And this is upskilling engineering. So our development and technology that we're doing has a huge impact to the UK economy. So 3.8 billion spend with around 5,000 UK suppliers. 72% of employees in engineering. 10 billion is contributed to the UK's gross domestic products that's coming through, and supporting full-time equivalent jobs is around about 143,000. So it's really important what we do to the wider economy moving forward. And this, up until questions here, is my kind of next slide here. Is I quite get asked this question quite often, so I drop it in and says, how do we be a part of your journey? And challenges moving forward is we want the right sweat and dynamic people coming in. So I'll leave this slide up here for recruitment, and we're recruiting in many areas of engineering at the moment, all different areas that are coming through. And if you want to come and be part of our 4.X journey and 4.X challenges and technology challenges we move through, please do so, and have a look at the website and the BAE Systems careers website. And if you work your way through that, it will show you all the kind of exciting opportunities that we come through. In my view, there's never been such an exciting time for engineering technology where we are today. And future plans with FCAS and Tempest, really key. Engineering technology, a very exciting place to be. So I'm just going to close that there and ask for questions. There's a few questions come through there, and yes, I will try and get a PDF document out. I don't know whether that came with your paperwork that comes through. I'm happy to get that through. That is coming through. And other questions as coming through is what are the big challenges in engineering, which I've kind of talked about, but I will kind of refer them. Is one of the biggest challenges is getting sweat and good people to work on these advanced products, getting people to come in engineering and get involved in such an exciting career. And engineers need to really consider about designing engineering products that are more affordable and more flexible than ever before. We really need to think out of the box and more sustainable, and that's our challenge. We're moving into a different era where customers want far more complex and technology driven products for the same costs as they did in the 1980s. And we really need to think how we do that. And the way 4.X, engineering 4.X is looking at that is this model-based systems engineering, and how we develop that, and how we develop the way we do things in a digital environment to make things safer, better as we come through. So I'm coming up to my time there. If there are no other questions, I'll give it a couple of minutes there. Apologies for the screen freezing. I don't know what happened then. I don't think you missed too much on there. That comes through. So no more questions, right? Okay, thank you. So come, by all means, look on the website, come and be a part of our exciting team as we grow up BAE Systems, and hopefully you find it was informative, and good luck. Thank you.